I want to discuss those cases specifically in which the tabular method will fail. There will be some cases where tabular method will always fail. Let's take a problem x square times e to the power x dx. So I think you already know about tabular method, right? First, in the first column, we put the signs, then we write the derivatives, and then we write the integrals. And the signs are always like this: positive, negative, positive, negative. And here we have to write, so one of these functions is going to be u and one of these functions is going to be v prime. So our u will come here, and v prime will come here.
So could the derivative I would probably take the derivative as e to the x.
No, here you will use the rule ILATE.
I'm sorry, not, I don't know how I say e to the x. Derivative would be x squared, and then integral would be e to the x.
Yes, exactly. So this is going to be in the derivative column, and this guy is going to be inside the integral column. Okay, so now we will write this. So here I'm writing x squared, and in the integral column I'll write e to the power x. So now we will keep on differentiating this function unless we get a 0. So derivative of x squared is 2x, derivative of 2x is 2, and derivative of 2 is 0. And we stop here. And then integral of e to the power x is e to the power x, e to the power x. Oh my god, I love e to the power x. Does not matter whether you differentiate it or integrate it, you're always gonna get e to the power x. Okay, now what do we have to do? We are gonna start with these two guys and we'll multiply it with this term, and then we'll take these two guys and multiply with this term, and then we take these two guys and multiply with this term.
And then you would get x squared e to the x, minus 2x e to the x plus 2 e to the x plus c.
Yes, that's it. So this is the tabular method, but let's also discuss those cases in which tabular method will fail. It will fail when you're not able to get a 0 in the derivative column. Okay, let's do some problem there. Okay, so for example, you have we have integral of x to the power 5 log x dx. Okay, I think in your homework as well, you got stuck in this problem. You're not able to do it by the tabular method. So let's write the signs, let's write the derivative and the integral, plus, minus, plus, minus, plus. So which function should we take inside the derivative column?
The x to the 5th.
X to the power 5th? Here? Okay.
Oh, for derivative? Well, in this case, I think that would probably, well, I guess when you're doing the integral of log x, it's going to be a little trickier. I I guess probably log x would be the best. Log x would be the best choice for derivative.
Exactly. Log x will come under derivative, and that will be our function u. If you were gonna do it by integration by parts, we will take this function as u and this function as v prime. That's what we will have to do eventually, because here tabular method will fail. Okay. So anyway, let's write log of x here and x to the power 5 here. The reason we are not taking log of x under integration is because its integral will be, too much complicated, although it can be done by using integration by parts, but we don't want to get into that. Now, derivative of log of x is 1 over x, then derivative of 1 over x is negative 1 over x square, then derivative of that is positive 2 over x cube. And now you will see that the powers of x will keep on increasing. But first you had 1 over x, then you have x square, x cube. So powers of x will keep on increasing. You'll never get 0. Okay? And on this side, it does not matter on this side what we are getting, but the problem is that we'll never get 0. So here this becomes x to the power 6, 1 over 6. This will be 1 over 6 times 1 over 7.
X to the
X
7.
to the
It's just going to
7.
keep going. And it's never going to be
Exactly.
useful for us.
Yes. So in those cases where you're not able to get 0 in the derivative column, then the tabular method, we won't be able to use tabular method. So in those cases, we will use our integration by parts. So now if we use integration by parts, so our u is log of x. So derivative of u becomes 1 over x, and v prime is x to the power 5. So its antiderivative becomes x to the power 6 over 6. And now we will use integration by parts. So that is uv minus integration of derivative of u times v. So that becomes log of x times v is x to the power 6 over 6 minus integral of derivative of u, that is 1 over x, and v times v, that is x to the power 6 over 6 dx. So now we can see that this will become 5.
It becomes easier to do it.
Yes. Now this integral, the main thing is the integral. If we are able to simplify the integral, so our life would be easier. So this becomes x to the power 6 over 6 minus, so this is 1 over 6, I'll write it outside. So this is integral of x to the power 5 dx, which is nothing but...
I got the answer.
You got the answer? Okay, great.
Yeah. I got log x times 1 over 6 x sixth minus 1 over 36 x to the 6 plus c.
Perfect. X to the power 6 log x over 6 minus x to the power 6 over 36 plus 6. Okay,